This is SpaceTime Series 25, Episode 99. Coming up on SpaceTime, the Dream Chaser spaceplane being looked at as a possible rapid response military transport. The Ariane VI begins launchpad testing as it counts down to its maiden flight. And Rocket Lab begins preparations for turning its highly successful Electron into a reusable launch vehicle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Sierra Nevada's Dream Chaser spaceplane will now begin flying cargo to the International Space Station for NASA in February next year instead of this year as originally planned. The delays have been put down to ongoing development issues and the COVID pandemic. But the news of the latest in a long string of delays for Dream Chaser comes as the United States Department of Defense announces plans to examine using Dream Chaser to provide a 3-hour point-to-point logistical transport capability to any place on the planet. This would allow the United States to deploy troops and equipment anywhere, anytime. Dream Chaser is designed to launch vertically into low Earth orbit aboard a Vulcan or Ariane VI rocket. It then lands horizontally on a conventional runway, needing no more room than a Boeing 737. Although current development is focusing on transporting up to 5 tons of cargo per flight for NASA, Dream Chaser was originally developed to transport up to 7 people on crew transfer missions to the International Space Station. In its current guise, each Dream Chaser spacecraft will include a 10-metre-long winged spaceplane, as well as a 5-metre-long pressurised cargo module called Shooting Star, which will be attached behind the spaceplane, carrying an additional 4.5 tons of supplies. Although very futuristic in appearance, the Dream Chaser lifting body design actually goes back well over 60 years, with its origin in the United States Air Force 1957 X-20 Dinosaur spacecraft, which would have been launched on top of a modified Titan III rocket. NASA continued its development in the 1960s and early 70s with a range of experimental spacecraft including the Northrop M2, the Martin X-23 Prime, the Martin Marietta X-24 and the Northrop HL-10. Then during the 1990s, NASA used the same basic design to develop the HL-20 experimental spaceplane, which eventually evolved into the X-38 Emergency Crew Return Vehicle, which would have been an emergency escape pod transported to the International Space Station in the payload bay of the Space Shuttle. It then would have remained permanently docked to the orbiting outpost until needed. However, the project was cancelled in 2002 following budget cuts. Meanwhile, the Pentagon is looking at using the Shooting Star cargo module as the basis for an autonomous unmanned military space station for research and development, training and operational missions in low Earth orbit. Sierra Nevada says it will redesign the module to include guidance, navigation and control systems for sustained free flight operations. It'll host specialized payloads, undertake experimental testing, manufacturing and assembly in microgravity, and carry a range of logistics. Longer-term plans could include higher elliptical and geosynchronous Earth orbits, as well as more distant lunar orbits. This is SpaceTime. Still to come, Ariane 6 undertakes launchpad testing, and Rocket Lab begins preparations for turning its highly successful Electron launch vehicle into a reusable rocket. All that and more still to come on SpaceTime. Development and testing of the European Space Agency's new Ariane 6 launch vehicle is now underway at the Kourou Space Port in French Guyana. A test model of the 63-metre-tall launch vehicle's central core has now been assembled for the first time. Ariane 6 is the first Ariane rocket to be assembled horizontally, which is simpler and less costly than the more traditional vertical assembly. After assembly, the rockets moved to the launch pad and then placed upright in the massive mobile gantry in order to validate the compatibility between all the components of the complete launch system. Ariane 6 is designed with 2 core stages, both powered by liquid hydrogen and liquid oxygen engines. The first stage has an improved version of the current Vulcan engine used on the Ariane V, while the second stage has a newly designed Vinci engine. But most of the initial launch thrust isn't provided by the liquid-fueled engines, but by massive solid rocket boosters attached to the first stage. Either 2 or 4 of these massive P120 SRBs will be attached to the core first stage, creating the Ariane 6-2 and 6-4 variants of the launch vehicle. These are the same solid rocket boosters which act as the core stage of the new Vega C launch vehicle. Soon, more testing will be done on Ariane 6's upper stage at a purpose-built DLR facility in Germany. Once in service next year, Ariane 6 will be capable of launching similar payload masses to the current Ariane 5, but at lower cost and more frequently. The heavy-lift ECA version of the current Ariane 5 can haul 10,865 kilograms into geosynchronous transfer orbit and 20,000 kilograms into low Earth orbit. By comparison, the Ariane 6-2 will launch 4,500 kilograms into geosynchronous transfer orbit and 10,350 kilograms into low Earth orbit, while the heavy-lift Ariane 6-4 version will carry 11,500 kilograms into geosynchronous transfer orbit and 21,500 kilograms into low Earth orbit. This report from ESA TV.
Exciting times for the European space industry as the combined tests for the Ariane 6 launcher have begun. The objective of these tests is to verify and validate the compatibility between Ariane 6 and its dedicated launch pad at Europe's spaceport in French Guyana. It's an essential dress rehearsal to prepare and train the teams before the rocket's inaugural flight. An industrial and human adventure with thousands of people spread across many European companies and institutions working together. The Ariane 6 program is managed and funded by the European Space Agency ESA, with Ariane Group being responsible for the design and development of the launcher itself. The French Space Agency CNES took responsibility for the construction of the new Ariane 6 launch base at Europe's spaceport, and Ariane Space will be the launch service provider for Ariane 6. With the combined tests at Europe's spaceport, a number of milestones have been achieved over the course of the summer. In the new launcher assembly building, teams from Ariane Group, CNES and ESA completed an important step of the process, the horizontal mechanical and electrical assembly of Ariane 6's central core. A few weeks later, the rendezvous. For the first time since its conception, Ariane 6 was able to meet its launch pad. The doors of the launcher assembly building opened to let Ariane 6's central core through. It took about 20 minutes at 3 kilometers per hour for the launcher to cover the 800 meters separating the assembly building from the launch pad. The rocket was then lifted from its horizontal assembly position to its vertical position. Ariane 6 is the first launcher in the Ariane series to be assembled horizontally. It makes it easier for the technicians and helps save time and money on every launch. Another element contributing to the competitiveness of Ariane 6 is its P120C solid rocket boosters. The P120C solid propellant motor is also used by Europe's other new launcher, Vega C. Sharing this key component means cost savings for both rockets. The P120C demonstrated its performance on the 13th of July with the successful inaugural flight of Vega C. But it's not only in French Guyana that testing of Ariane 6 continues. In the purpose-built test facility in Lampolshausen, Germany, crucial firing tests of the upper stage engine will soon begin. Then the upper stage will undergo further testing at ESA's STEC Technology Centre in the Netherlands. Now only a few steps remain before the teams at Europe's spaceport can switch from the test models they're using for the combined tests to the flight hardware that will be used for the inaugural flight of Ariane 6. A first, which will be followed by many launches, continuing Europe's heritage of independent access to space.
This is SpaceTime. Still to come, Rocket Lab begins preparations designed to turn its highly successful Electron launch vehicle into a reusable rocket. And later in the science report, the Lancet Commission says an estimated 17.9 million people have now died from COVID-19. All that and more still to come on SpaceTime. European Space Agency has witnessed one of the final launches of its Ariane V workhorse rocket carrying a new telecommunications satellite into geostationary orbit. The launch from the European Space Agency's Kourou Space Port in French Guyana carried the Eutelsat Connect VHTS telecommunications satellite. Built by Thales Alenia Space, the 6.62-ton satellite uses the world's most powerful digital processor and will provide high-speed internet access across Europe. The 8.9-metre spacecraft is equipped with new antenna deployment and positioning mechanisms within the antenna tracking system. It also features new generation batteries and innovative new structural panels. Ariane Space Flight VA528 was the 114th and fourth last launch of the Ariane 5 rocket, which has had a 96% success rate. Only 3 launches are left, 1 in December and 2 next year. The last being the Jupiter Icy Moons Explorer or JUICE mission, which is bound for the Jovian system and is slated to launch on April 5th. Rocket Lab has successfully test-fired a used but refurbished Electron Rutherford core stage engine for the first time. The test was a significant step in the company's efforts to turn the Electron into a fully reusable launch system. The full-duration, full-thrust test-fire involved an engine that had previously flown on the There and Back Again mission, which launched back on May the 2nd this year. That flight was the first time Rocket Lab attempted a mid-air capture of an Electron first stage. The Electron deployed parachutes to slow its descent from space before a helicopter plucked the rocket from the sky as it approached the Earth's surface. However, high winds saw the Electron stage ultimately released for a soft ocean splashdown by the chopper pilot. It was later recovered by a Rocket Lab vessel and returned for detailed examination and ultimately refurbishment. The refurbished engine has passed all the same rigorous acceptance tests which Rocket Lab performs on its new engines. This is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.